Okay, welcome to Unit 2, Lesson 1, Segment and Angle Bisectors. We're going to start off again with a few definitions to get us ready to go into this lesson. The word bisect means to divide in two equal parts. So bisect, it's going to divide into two equal parts. A segment bisector is a segment, ray, or line that intersects a segment at its midpoint. Now if we just look at that word, segment bisector, whatever is going through that midpoint is going to bisect our segment, which means it's going to divide it into two equal parts. And the midpoint of a segment is the point that divides the segment into two congruent segments. It's the middle of that segment. So midpoint is the middle. And a segment bisector goes through the middle, which means that the segment bisector bisects our segment. So we're just going to do a couple examples. Let's assume that this line AB here is going to bisect all of our segments. So let's start with number 1. We see that line AB is bisecting segment CE. We know that CD is 4 and we want to find DE. Well, because of our definitions from the previous page, we know that if it's bisecting, it's cutting it in half. So if 1/2 is 4, which is CD, that means the D also has to be 4. Now what do you think 2 is going to be? We should look at that for a second, figure it out. Okay, so we see that line AB is now bisecting segment XZ. And we have XY, which we're trying to find, and we know that YZ is 7. Well, again, because of our definitions of bisectors, if YZ is 7, then XY also has to be 7. And then just a note down here on how to indicate that segments are congruent. If we have this statement that segment AB is congruent to segment CD, if we want to show that with the two segments, we have our two segments, we have AB, we have CD. What you do to denote that is you just put a dash like this through the segments. That means that those two segments are congruent. And that also means that any other segment that has this one dash with it will also be congruent. Okay. Now we're going to talk about the midpoint formula. Sometimes you're going to have a segment that's on a graph and you don't know what the midpoint is and you can't count to find it. So we have this formula. So to find the midpoint, you take the average of the two endpoints of your segment. We're going to call them x1, y1 for the first, x2, y2 for the second. And we get this formula right here. We're going to take x1 plus x2, divide that by 2 to find the average. We do y1 plus y2 divided by 2 to find the average. And that new point that we get is where our midpoint is. So let's do a couple examples. So in this top left corner up here, we'll start. We're going to find the midpoint. Now if it's a segment that is already going in a straight line, we can count sometimes. So if we count here, let's see, 1, 1, 2, 2, and then we see that they're going to meet right here in the middle. So that's where our midpoint should be. Well, let's actually use the formula to figure it out. So our first point is at looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Looks like it's at negative 12. 1, 2, 3, 4, 5. And then this point here is at negative 7, 5. So we're going to plug this in our formula. And I'm just going to call this first one x1, y1, and the second one x2, y2. So we're going to have negative 12 plus negative 7 divided by 2, 5 plus 5 divided by 2. Negative 12 minus 7 is negative 19. Negative 19 divided by 2 is roughly negative 9.5. 5 plus 5 is 10. 10 divided by 2 is 5. So our midpoint should be at negative 9.55. So let's count. It's about right there, where we guessed it should be. I want you to pause the video and try to use the midpoint formula on the next 3, and then play the video again to see if you got them right. Alright, I'm going to move up here to the top right hand corner. Looks like my 2 points here are going to be looks like this is 12, 7, and up here it's 15, 10. So I have 12, 7, 15, 10. So I'm going to put that in the formula. We have 12 plus 15 divided by 2, and 10 plus 7 divided by 2. Which gives me 27 divided by 2 and 17 divided by 2, which as decimals become 13.5 and 8.5. So our midpoint should be right there. Our next example, this looks like it's at negative 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 9. This appears to be at negative 7, negative 10. Plug these in the formula. 7 divided by 2, negative 9, 10 divided by 2. Again, a very key note when you're using this formula, if you say that this is your x1, this has to be your y1. You can't mix them up. If you say one of them is an x1, then that corresponding y has to be y1. So we do this, get negative 10.5, and here we get negative 9.5. It looks like our dot should be right there. Okay, last one. This point here is at 2, negative 4. This is at 4, negative 3. So we get 2 plus 4 divided by 2. Negative 4 plus negative 3 divided by 2. This gives me 3. This gives me negative 3.5. So it looks like my midpoint is going to be right here. Next, let's talk about angle bisectors. An angle bisector is a ray, segment, or line that divides an angle into two congruent angles. So what that looks like is that if we have an angle, what's going to happen is we are going to have either a ray, segment, or line that's going to go through the vertex. And when it goes through the vertex, I'll just draw a ray, it's going to bisect and turn these into two congruent angles. So if this is x, this is also x. They're the same degree measure if it is bisected. So let's do a couple examples. All of our angles here for 1 and 2 are bisected, and we just have to find the missing angle. So in number 1, if one of the angles is 20, that means that this second angle also has to be 20 degrees. In number 2, if this angle is 60, then y also has to be 60 degrees. These angle bisectors and segment bisectors are pretty straightforward. Now just a note on how to write congruent angles. If we see that angle ABC is congruent to angle DEF, what we do is we draw in these little symbols like that. They work just like our dashes did for segments. Anything with one curve is going to be congruent to everything else with one curve. So this says that ABC is congruent to DEF. That is it for lesson 1.